Dear students, today we are going to see about multiple layer perceptron. Just I will share my screen. Yeah, I hope you can see my screen. Yeah, multiple layer perceptron. So last class we have seen about the single layer perceptron, and today we are going to see about the multi-layer perceptron. Right. So how will you see the difference between the unilayer or single layer perceptron and multi-layer perceptron is there you will have only the input layer and the output layer, but here we are going to have, in addition to this, we are going to have the hidden layers. Okay, just we will see the hidden layers come, how we will do the computation. So here we are getting the input in the input layer, right? And then we are computing all the sub functions. That's why that we will call it as like a hidden layer, and then processing the result or subfunction to get the output, right? So even you will have multiple, okay, hidden layers. That also you will see how to calculate using the formula, right? So for example, this is the architecture of multi-layer perceptron, right? So as I told you, these are the input layers, right? So in which the input layer which have to be given weights, that is W11, W12. Likewise, we are just giving the weight to the input layer, and along that we are just going to add the bias value into it. And this is the first hidden layer, right? And in which if we are just adding again weights, okay, again adding the weight, and then with the bias if we are just adding, then another hidden layer. Likewise it will go on, right? Finally you will get the effects, that is the output layer, right? So in the output layer there is no uh, uh, function here. Okay, so directly in the output layer there is no activation function will be happening. Only in this hidden layer we will see, right? See, this is how the activation function it is functioning. That is each and every input layer along with the weight that we are going to multiply it, and then with adding with the bias value. So that will give the H1 and H2 hidden layer, and then again from here we are adding the weight and keep on going on. So once it reaches to the fx, that is the f of x, that is the final output layer in which we are not going to give any weight or adding with the bias. We are not going to do it. Okay, so that is how we are going to finally end the process. So f of x, that is the output layer. Here there is no activation function. Okay, so when we are using the binary, we are using the sigmoid. Okay, so based on design, and if it is a multi-class means we are going for softmax. Okay, so this is a method we are going to do it. So in the output layer. So if any error occurs, so that is the time we have to go for back propagation. After getting the result of f of x, we have to go for back propagation. That means what? We have to go back and then we have to change the weight. Got my point? And then improving the accuracy. So that is also possible in multi-class perceptor, right? So that is the added advantage of multi-class perceptor. Okay. When we see about MLP now, right? Till now we have seen about how to multiply with the weight and how we are going to add the activation. Okay, so and then we'll get the hidden layer, and we have seen, right? Now we will see about what is this MLP is all about. It's a feed forward neural network which one or more hidden layers it has, right? So it has the input layer and then hidden layer. Okay. So input layer we will call it as like a features, as you know, right? And then the output layer will be like the target, or here we will call it as like a classification or regression method, which will be used, okay, to classify the final target, right? And then hidden layers, that is non-linear transformation, right? So here we are using the propagation, back propagation for training. Okay, so that is we are just changing the weight to improve the accuracy, right? So why we are using TensorFlow for MLP? Okay, multi-layer perceptron. Why we are using TensorFlow? That's a question you should able to answer. That means we are using high value API for easy model building. Okay, so or otherwise it is like a complex structure, right? So we have to make it as like a easy model building so that we are going for high level API. That is actually TensorFlow. High level API we are going to use for simple model building, right? Easy model building. And also we are using GPU acceleration. So in order to visualize the information, we are going to use graphical processing unit as a device or CPU, which is ready, we will use. And GPU is working means it will give, okay, some more better visualization, right? And also, we are using this TensorFlow for MLP. The main usage is built-in propagation. Back propagation is available, and optimization that also can be done easily, right? So that is the main thing. Again, it is not necessary you have to write the code to do this process. Easily, we can use it as like a tool, okay, which is there in the TensorFlow, right? Okay, so these are some of the added advantage. That's why we are using in MLP. Okay, there will be so many hidden layers. To make it simple, we are going for the TensorFlow. So in forward propagation, we are having Z equal to weight into X plus B bias, right? So that is how we are making, and A equal to F of Z. Okay, that is the final output layer. Okay, so activation function we are using sigmoid, ReLU, okay, tan H, softmax for multi-class classification. So depend upon the different category, we will use the activation function also in a different way. Okay, each and everything is a computation method to do the activation function. In back propagation, what we are doing, first we have to minimize the loss function using a gradient descent. Okay, and then we have to, what are the steps for going for it? So main objective is we have to minimize the loss function, and also we have to compute the forward bias. Okay, first forward bias we have to go for it. That is from the input layer we are going to multiply with the weight, and that is the forward bias, right? And calculate the loss using a loss function. Okay, so we are using the loss function to calculate the loss if it is a cross entropy. Okay, depend upon the different architecture, the this one also will vary. Okay, loss function. So compute the gradients via chain rule to compute the gradients for back propagation. Okay. So mainly in back propagation, we are updating the weights and biases to minimize the loss function, because in the forward pass, we will have a loss function. So back propagation, we are going for it to reduce the loss function. So for that, we are updating the weights. Okay. Already we have given weight added with the bias and get the output layer, right? So we are go back propagation and then we are changing the weight to, okay, so using an optimizer, that is Adam, SGD and all, we are using it as like an optimizer to update the weights. Okay, so gradient descent to minimize, okay, to minimize the loss function. Okay, to minimize the loss function, we are using this gradient descent, right, to minimize the loss function. So this is the formula we are using. Theta equal to theta minus alpha, okay, into del L by del naught. Del L by del naught is a gradient of the loss function with respect to theta, right? And L is the loss function actually. Okay, but this ratio will give the gradient of the loss function with respect to theta. Okay, so that we have to subtract with the theta value. Okay, so we have to subtract with the theta value, then you will get the original theta, right? So until that time, we are going to weights and bias is continuously we have to use it to update rule for each parameter theta. Okay, weight W and bias B is used. Okay, so that only we have seen now. So loss function and optimizer, that also will vary. When it is a binary classification means we have to go for binary cross entropy. For multi-class means categorical cross entropy, and for regression means mean square error. These are the things that is used when it is a loss function, okay, to bring back the original. So optimizer we are using SGD, gradient descent, okay, ADAM for adaptive moment estimation, and RMS prop. Okay, these are some of the optimizers, okay, which are used. As I told you, we are using this to change the weight, okay, which is already given. Okay, given. So that's all about it. Okay, and these are the formula we are using for the loss function. This is for the binary. So we are having only one summation, that is I equal to 1, in which we are going to find the yi logarithmic of mean value of y plus 1 minus yi, the logarithmic of 1 minus yi cap. Okay, that means the mean value, right? So that is how we are going for the binary cross. But categorical, just we are going to have for two values. Okay, that is sigma I equal to 1 to n, sigma j equal to 1 to n, and then y ij, the logarithmic of y bar ij. Okay, so that means we are going for the categorical cross entropy. Okay, and mean square error for regression means we have to go for 1 by n, that is the whole number of values, right, in that particular column. Say summation of I equal to 1 to n, in which we are getting the input value, that is yi, and yi bar is the mean value, the whole square, right? Either yi bar can be put it here or here, because anyhow, even if it is a negative value also, we are making it into square, so it will become a positive, right? So that is how we are finding the mean square error as well, right? So I hope with this, the theory part of MLP is over. In the next video, we will see about the code of MLP, so that you will get the clear picture over it. Okay. So thanks for joining, and all the best. Thank you.